In this video, we're going to talk about how to find a confidence interval for a population mean, and also how to easily find a z-score that will help you to get the confidence interval, and also determining the value of the margin of error, also known as the error bound for the mean. So we're going to work on two example problems to illustrate how to do this. Number one, the average test scores in a physics class is normally distributed with a standard deviation of 5.4. 50 scores with a sample mean of 79 were selected at random. Part A. Find a 95% confidence interval for the population mean test score. Go ahead and try this problem if you already know what to do. So we're dealing with a normal distribution. And that normal distribution has a population mean. We don't know what the mean is. However, we can estimate the population mean by means of a confidence interval. We know the standard deviation of the population, that's 5.4. The sample size is 50. 50 scores were selected at random. And the sample mean, x bar, is 79. So with this information, how can we construct a 95% confidence interval? The population mean, mu, is going to be between x bar minus z alpha times sigma over the square root of n. And its upper bound is going to be x bar plus z alpha times the population standard deviation divided by the square root of n. The confidence interval is going to range between the lower value, or the lowest value, is going to be x bar minus the EBM, the error bound for the mean, and the highest value is x bar plus EBM. So notice that these two are the same. So therefore, the EBM is what you see here. The error bound for the mean is z alpha times sigma over the square root of n. So when writing the confidence interval, it's going to range between x bar plus or minus z alpha times sigma over the square root of n. Now the first thing we need to do is determine z alpha. Z alpha is going to be somewhere to the right of the mean. And the area that corresponds to z alpha is going to be the area to the left of z alpha. So the area of the shaded region highlighted in blue. Now this is a formula that can help you to calculate that area to the left. And here it is. The area to the left is going to be the confidence level expressed in decimal form plus 1 divided by 2. So the confidence level is 95%. So that's 0.95 as a decimal. So this is going to be 1.95 divided by 2. And so you should get 0.975 for the area. So that's the area of the shaded region. It's 0.975. Now what you need to do is you need to take the positive z-score table and get the z value that corresponds to this area. Now there's a lot of different z-score tables out there, but you want to use the one where it gives you the area from the left, not the area from the right. So keep that in mind. So using the appropriate z-score table, if you search for the area of 0.975, you should get a z-score of 1.96. So once you have that, you can now plug it into this expression. The next thing we need to calculate is the standard deviation of the sample mean, which is going to be the standard deviation of the population divided by the square root of n. So the standard deviation of the population is 5.4. The sample size is 50. So that's going to be 5.4 divided by the square root of 50, and you should get 0.76368 if you round it. So our 95% confidence interval is going to range from, let's see, x bar is 79, and then it's going to be plus or minus z alpha, which is 1.96, times the standard error, or the standard deviation of the sample mean, which is 0.76368. 1.96 times 0.76368, that's 1.4968. So the lowest that the mean is going to be in this 95% confidence interval is going to be 79 minus 1.4968. So that's 77.5032. And the highest is going to be 79 plus 1.4968. And so that's going to be 80.4968. So this right here is our answer for part A. So that is the 95% confidence interval. We could say that we're 95% confident that the mean for the population, or the mean of the average test scores in this physics class, is between 77.5032 and 80.4968. So if we were to take 100 samples, about 95 samples, or at least we expect that 95 samples will have a mean between these two values. The other 5 samples will have a mean outside of those values. So that's the basic idea behind the confidence interval. So we're 95% confident that the mean is going to be between these two numbers. Now, what about part B? What is the value of the margin of error? The margin of error, also known as the error bound for the mean in this example, is z alpha times the standard error. So it's 1.96 times the standard deviation of 5.4 over the square root of the sample size. And it's basically going to be this number that you see here. So if you were to type this in your calculator, you should get 1.4968. So that is the error bound for the mean. That is the value of the margin of error. Here's another problem that you could try. Feel free to pause the video and work on it. Number 2, the average test scores in a chemistry class is normally distributed with a standard deviation of 6.5. 100 scores with a sample mean of 82 were selected at random. Find a 90% confidence interval for the population mean exam score. Go ahead and try it. So let's write down what we know. The standard deviation is 6.5. The sample size is 100. 100 scores were selected at random. And the mean of those scores is 82. So we need to estimate the population mean using a confidence interval. So let's start with this expression. X bar plus or minus z alpha times sigma over the square root of n. So first, let's calculate z alpha. And we need to calculate the area to the left in order to do this. So it's going to be the confidence level plus 1 divided by 2. The confidence level is 90%, but as a decimal, if you divide 90% by 100, this will give you 0.90. So if we add 1 to that, that's going to be 1.9. And 1.9 divided by 2 is 0.95. So using the positive z-score table, which gives you the area from the left, locate a value of 0.95 and then find the corresponding z-score. So for 0.95, we don't have an exact value, but we got two numbers of interest. For an area of 0.94950, according to the z-score table that I'm using, the z-score that corresponds to it is 1.64. And there's another one that's close to it, 0.95053. The z-score for that is 1.65. Now, both of these two numbers, they're equidistant from 0.95. So to get the best z-value, we can average those two values. If you add them up and divide by 2, you'll get the number in the middle, which is 1.645. So that's a quick and simple way in which you could find the z-score from a confidence level value. So now that we have the z-score, we can go ahead and construct the confidence interval. So let's plug in everything into this expression. So x bar, that is 82, and then it's plus or minus z, which is 1.645, times sigma, which is 6.5, divided by square root of n. The square root of 100 is 10. So it's 6.5 divided by 10 times 1.645. So this gives us 82 plus or minus 1.06925. So to get the minimum value in our confidence interval, it's going to be 82 minus 1.06925. And so that's going to be 80.93075. And then to get the maximum value in the confidence interval, it's 82 plus 1.06925. And so that's going to be 83.06925. So this right here is our 90% confidence interval. So what this means is that we're 90% confident that the average test score in the chemistry class, that is the population mean, is between 80.93 and 83.069. So if we had 100 samples, about 90 of those samples will have a mean between these two values. The other 10 samples we expect will have a mean outside of those two values. Sometimes when you have a homework problem, you need to explain what these range of values mean in the context of the problem. So that's what you do if you have to do that. Now, part B, what is the value of the margin of error? The margin of error, or the error-bound mean, is z alpha times sigma over the square root of n. So that's 1.645 times 6.5 over the square root of 100, and it's going to be, once again, this number. So it's 1.06925. So that is the error bound for the mean. That's our EBM value. So that's how you can find a confidence interval and determine the value of the margin of error. Hopefully these two examples clearly illustrates how you can do that. Now here's a question for you. What is the difference between the confidence interval, CI, and the confidence level, CL? What would you say? The confidence interval is the range of values that we expect the population mean to be located in with a certain probability. So as we said before, the confidence interval, it varies between a minimum value and a maximum value in which we expect the mean to be located in. It's the sample mean minus the margin of error to the sample mean plus the margin of error. So that is the confidence interval. The confidence level is the area under the curve in which we expect the population mean to be located in. So in the last example, we saw that the confidence interval, it varied from approximately 77.93 to 80.069. That's the confidence interval. It's a range of values. The confidence level gives us the area under the curve. So for a 90% confidence interval, the confidence level, my L looks terrible, the confidence level is 0.90. So that will be the area under the curve in which these range of values will exist in a normal distribution. Now, the confidence level is equal to 1 minus alpha. Alpha is the probability that the mean is outside of the confidence interval. So if the confidence level is 90% or 0.9, alpha is the 10% or 0.10. So let's illustrate this with a picture. So let's draw our normal distribution curve. So here is the population mean. Let's say this is positive Z alpha, and we're going to say this is negative Z alpha. So the area under the curve of the region shaded in blue, that's going to be our confidence level. So that area is 0.90. So the 90% confidence interval is going to range between these two values. So our minimum value will be x bar minus EBM, and our maximum value will be x bar plus EBM. Now outside of that, we have the area shaded in red. So we said that alpha is 10%. So to the right, this is going to be alpha over 2. That's going to be 5%. And to the left, that's also alpha divided by 2. That's also 5%. So alpha is the area under the curve outside of the confidence interval, whereas the confidence level is the area under the curve within the confidence interval. Now let's talk about the effect that the confidence interval and the sample size have on the margin of error. So here's a question for you. If we increase the confidence interval, will the margin of error increase or decrease? What would you say? So let's say this is the length of a 90% confidence interval. The margin of error is going to be half of the length of the confidence interval. So that's going to be our EBM value. Now, let's say if we increase the confidence interval from a level of 90% to a level of 95%. A 95% confidence interval will be longer than a 90% confidence interval. So because the EBM is half of that, the EBM is going to be longer as well. So as you increase the length of the confidence interval, the margin of error increases as well because they're directly related. The EBM is half of the confidence interval. Now what about if we increase the sample size? What effect will that have on the margin of error? Now keep in mind, the margin of error, the EBM, or the error bound for the mean, that's Z alpha times sigma over the square root of n. Notice that n is at the bottom of the fraction. Whenever you increase the denominator of a fraction, the value of the entire fraction goes down. It's an inverse relationship. Therefore, as you increase the sample size, the margin of error decreases. So there's two ways in which we can decrease the margin of error. The first way is to decrease the length of the confidence interval. If we decrease that, the margin of error will go down. The second option is to increase the sample size. Those are two simple ways in which we could decrease the margin of error. So that's it for this video. Hopefully it gave you a good introduction into confidence intervals and identifying the value of the margin of error. Thanks again for watching, and if you like it, don't forget to subscribe.